take a look at our last section for this week, which is 7.4. So 7.4 is all solving equations, okay, using all the properties that we've learned. So converting between log form and exponential, special properties of logs, the combining and splitting of logs, and the change of base formula. Okay, other things that I mentioned already will come up, is like factoring, distributive property, basic algebra type stuff. All right. So let's just, we'll start out just looking at examples and see how many we get through. All right, so first thing I want us to do is solve that. When I look at that, one thing I see that's good on the left and on the right is the logs have the same base. That's always a good start. All right, so we've got two logs with the same base. Now, what I'd like to do, the right-hand side, I can't really do a lot with it, but there is something I could do on the left that we learned yesterday. Everyone sees something there that I can change. And once I do this, I think we'll be able to figure out the answer. Christian?
Can you change the 2 to an exponent?
Yeah, let's put the 2 back as an exponent. So now we have log base 5 of x squared equals log base 5 of 9. Okay. What did I just say already matches on each side? The base, right? The log with the base. So these parts already match. So the only thing left to make sure that matches up is the, what do we call this thing again?
Argument.
The argument. We've got to make sure that the argument here matches the argument there. So as long as we can find a number for x that makes that happen, that's the answer. So what would make the arguments match?
3.
3. That's it. If you aren't sure, and you're still like, how would you figure that out? Well, just take what's in the blue box on the left, set it equal to the blue box on the right, and then solve the equation. Take the square root of each side. Square root of 9 is 3. So anytime you have an equation and the bases already match, it's very easy to solve. Just set the arguments equal to each other and figure out the answer. If the bases don't match, then it's a little harder. We'll take a look at a little bit of one of those later on, but not right now. Yeah, so you're going to have one very similar to that on the test. Any questions on the first step of moving that exponent, or then how we got 3? Okay, so that's the first one. Okay, let's look at this one. All right, so I have the sum of 2 logs equal to 1. So it's log base 4, and the first argument is x plus 3, plus log base 4, and the second argument is 2 minus x. Now, I've got 2 separate logs with the same base on the same side. What can I do if I have 2 logs that are separate that we learned yesterday? Yep.
You can combine them by putting the log in front and then putting both of them multiplied.
Yes, I can combine them into 1. And Joe just said we have to combine them by multiplying because there's a plus sign there. So it's going to be, Joe, can you tell me what it'll be? What times what?
It will be x plus 3, close parenthesis, open parenthesis, times 2 to the minus x.
Yep. And then equals 1 just stays where it is. All right. Now we've got to do that out. So what do you call this? And I mentioned it earlier before we started the lesson. When you have to do all this stuff out.
Distributive property.
You got to do the distributive property. Okay. This is, in fact, you're doing the distributive property twice. Some people call it FOIL, but it's just the distributive property twice. So we've got log base 4. And let's do it out. So x times 2, what does that give me? 2x. And then x times negative x. Negative x squared. 3 times 2 is 6. And 3 times negative x? Negative 3x. All right, now there's a little bit that we want to do with that. Generally, when we have something that's quadratic, we like that one in the front. So let's write it this way. Negative x squared, we'll put that first. And then what could I put next? I usually put the x term next, but I got a couple of them, so we
Combined.
can combine them. Yep.
Minus X.
Minus x. 2x minus 3x is minus x plus 6 equals 1. All right, so now we've used the property where we can combine the logs, so there's nothing left to combine. There's no numbers in front that we have to put back as exponents. There's only one other thing we know how to do with an equation that's in log form. One of the first things we learned.
Make it exponential.
Make it exponential. So once you get to this step where you only have a single log left, that's the only thing to try. So let's start out with my base. Okay, what's my base here?
4.
Can you say it again? Eric, what's my base?
Is everything in the parentheses? Or the brackets?
No, what's in the brackets, that's something else. Yep.
Negative x squared.
So if you had this on lined paper, right, like that?
Oh, that's the base.
Yeah, the
Oh,
base.
it's 4.
The base is 4. Okay, the base is what's lower than everything else. So 4. And what would the exponent be?
2.
1.
1. Logarithms equal exponents. Okay, logarithm always equals the exponent. And then what ends up by itself on the other side?
The argument.
The argument, all the stuff in the brackets is your argument. Negative x squared minus x plus 6. Now from here, that's an algebra 1 equation. It's just a quadratic, and you can either use quadratic formula or you can factor it. A couple things I would simplify though. What does 4 to the first power simplify to? 4. And then when you're solving a quadratic, we don't usually like it equal to 4. We usually get it equal to another number.
Minus 6.
Not 10. What do you always want to get a quadratic equal to when you want to solve it?
0.
0. So we want to move that 4. Well, you can do it either way. I'm going to move everything to the left side. Let's just do it that way. And if you're like, why don't you just move the 4 to the right? I'll show you why in a second. So we're going to move the 6, the negative x, and the negative x squared. So how would I move 6 to the other side?
Make it negative 6.
Make a negative 6. That's gone.
Are you doing it because you want the x to be negative, a positive number?
Yeah. And there's a couple ways you could make the negative x squared positive. But yep, that's why I'm doing it. So I'll do it in a couple steps. 4 minus 6 is negative 2. All right. How would I move the negative x?
Make it positive.
Positive and positive. Let's do the other one at the same time. How would I move the negative x squared?
Same thing.
Plus x squared plus x squared. So now I have nothing on the right-hand side. So that's 0. And on the left, I have positive x squared, which anytime I'm dealing with a quadratic, I'd like x squared positive. Makes things easier. Plus x minus 2. Okay. Any questions on that?
Is that the answer?
Well, we got to solve for x. All right. So what's one way you can solve a quadratic equation? Factoring. What's the other way if factoring doesn't work? Quadratic formula. Some people like the quadratic formula because there's no guessing involved. With factoring, you kind of guess and see if it works. But I like factoring because it's faster, as long as you know how to factor. So whenever you want to factor, what's the first thing you write down? Before you even think about letters and numbers.
Wouldn't it be 1?
No, we're not even going to think about numbers and letters yet. We're going to write these down, and then we're going to put numbers and letters and symbols inside them. Yep.
Parentheses.
Parentheses. How many sets? 2 sets of parentheses. Now I have to figure out my first 2 terms. What times what gives me x squared?
X and X.
X and x. I've got a positive middle term and a negative constant. Whenever I have a positive middle and a negative constant, what does that mean my signs have to be in parentheses?
One positive, one negative.
One positive, one negative. There's three different situations. Positive, positive, negative, negative, and then one of each. Okay, this is one of each. Now I need two numbers that multiply to give me 2 and subtract to give me 1.
1, 2.
1 and 2, and it does make a difference which one I put where. So do I want to do 1 and 2 or 2 and 1?
2 and 1.
Let's try it and see what happens. So I get x squared, looks good. X times negative 1 is negative x. 2 times x is 2x. Negative 1x plus 2x, perfect, 1x. So we got it. Now, we have something times something equals 0. That's the goal. If you multiply something times something and get 0, what does that mean?
Multiply by 0.
Right, you had to multiply by 0. So if you multiply two things together and get 0, then one of them must have been a 0. Right? Either the first one or the second. What number would you plug in for x to make the first factor 0? Negative 2. And what number would you plug in for x to make the second factor 0? 1. And those are two possible answers. Any questions on those?
So that's the answer to the problem that we started 10 minutes ago?
That's the possible answers to the problems we started about 10 minutes ago. All right. As I said, possible answers, because we have to check them. We have to make sure they work. So we've got to make sure that whenever you plug those numbers in, you're not taking the log of a negative, because we said you're not allowed to take logs of negative numbers. So let's check. Bless you. Let's check 1 first. Let's see if it works. Bless you.
Thank you.
If I plug in 1 right here, what would that argument turn into? 4. Can I take the log of 4? Sure, it's a positive number. What if I were to plug in 1 right there? What would that argument turn into? 1. Can I take the log of 1?
Mm-hmm.
What is the log of 1? 0. Exactly, that's a special property. And then if I plugged in 1 here, I get log base 4 of 4. What's that?
4. 1.
1. Remember, when the base and the argument match, the answer is always 1. That's another special property. So you get 1 plus 0. Does that equal 1? Yeah, that answer works. So this one's fine. And let's check negative 2. What's negative 2 plus 3? 1. What's the log of 1? 0. Yeah. And what if you plug in negative 2 in the second argument? What do you get?
4.
4. So it's log base 4 of 4, which is how much?
1.
1. So you get 0 plus 1 again. Oh, we got 1 plus 0 last time. This is 0 plus 1. Does that equal 1? Yeah. So both answers work. There's 3 cases that could happen. Both answers work. One answer works, one answer doesn't. Or both answers don't work. Okay. If both answers don't work, you might see this as like a choice. If it was a multiple choice question, that symbol means empty set, and it's a Norwegian letter. That's what that symbol is. It's a letter from the Norwegian alphabet. Right. People have seen that letter before? Symbol? It means empty set, no solution, kind of the same thing. But this one's not no solution. They both work. Right. Any questions on that one? So as long as your algebra skills are okay, everything from here down was all solving a quadratic equation. The only steps that involved anything that I explained this week with those three. That's it. Yeah.
Wait, so will a problem like that be on the test?
Yeah, you could have something like that. Yeah. So you got to know how to solve a quadratic. Mhm.
I remember from yesterday, like a lot of the answers still had like they still looked complicated.
Well, yesterday we weren't really solving equations. All we were doing was taking things and combining or separating. So when you're combining and separating, you're just taking what you have and just kind of rearranging it. You're not really getting x by itself, which is what we're doing today. So every answer today is going to say x equals and then a number. Or x equals, maybe you get two numbers, like in the last problem. Okay, let's look at this one. Log base 3 of x equals 9. Easier than the last one. What could I do with that one?
Exponential.
Yep, may change it to exponential form. There's not multiple logs there, so you're not going to combine two of them together. That's really the only thing you can do. What would you get if you make that exponential? What to the what would equal what? Scott? 3 to the 9th equals x. And that's it. So that one's a lot easier. Now, these answers can get kind of big. I mean, 3 to the 9th is big. I don't think it's in like the trillions big. It's about 19,683, so it's kind of big. If it starts to get that big, they probably won't have you do it out. Right? You can just leave it as 3 to the 9th. Right? But if it's a multiple choice question and they do it out, then do yours out and see which one matches. Any questions on that one? So not all of them are as long as some.
What would that look like if you did it out?
If you did it out, it would be 19,683. So again, it's big, but it's not even in like the millions. So something probably a little bigger you could do. You know, you can't really do it in your head, but you could do it on the calculator, and it's not too big. All right, so 2 to the x equals 5. This is very similar to the first kind of questions I asked you on Monday. Okay, I started out with like 2 to a power equals 8, 2 to a power equals 16, and those were easy. And then I changed it to something like 2 to the x equals 5, and now it gets a little harder. Because 2 to the second power is 4, so 2 is too small. 2 to the third power is 8. So when x is 3, that's too big. So the answer is between 2 and 3. Okay, what could I do with this one? Yeah.
Could you change it to log?
Yep, change it to log form. So we'll start out with equals log. And logarithm always equals what kind of number?
Exponent.
Exponent, that's perfect, because my exponent is the variable. I just got the variable by itself. What do I need next on my log?
The base.
I need the base. What's the base?
2.
2. And the last thing I need?
Argument.
My argument, which is the thing that's all by itself on the other side. So that's the answer. But I can't type that in on the calculator. How come?
Because it's a base of 2.
It's a base of 2. The calculator can only do which bases?
10 and E.
10 and E. That's not 10 or E. So if I want a decimal, I got to rewrite it. How would I write that so I can type it in? Got it?
Log of 5 over log 2.
Yep. Or another way you could do it?
ln.
Yep, you could use ln5 over ln2. Same thing. All right. So now what we'll do is we'll type it in and just get an approximate answer. So log 5 divided by log 2, parentheses, again, make sure you watch those. It's about 2.32, which is exactly where we expected the answer to be. We knew 2 squared was too small. 2 cubed is too big. So it's in between the two. Questions on that one? Okay, so that's again another pretty quick one. Pretty much the same as the last one. Can anybody tell me what two numbers x is going to have to be between? Like 3 to this power is too small, 3 to this power is too big. Yeah, 3 squared is 9, that's too small. 3 cubed is 27, that's too big. So it's going to be pretty close to 3, maybe 2.7, 2.8, somewhere around there. Okay, so how would I rewrite that one so I can figure out exactly what it is?
Log
All right, so we'll start with log. Yep, what else?
x
X equals, okay.
base of 3.
Base of 3.
Argument 24.
Argument 24. And we don't even have to rewrite it this time. Let's just rewrite it as we type it in. So what would I press on the calculator to type that in? Yep.
Log of 24 divided by log 3. No.
No.
You gotta go back.
Oh, okay.
Yeah. See what you tried to do there. You gotta put parentheses around 24.
Like that.
Yeah. And then divided by log of 3 parentheses.
Gotcha. Perfect. About 2.89. Any questions on that one? As I started you out with kind of an easy one where you just had to move a power in front, and we did a harder one. Now we've done 2 or 3 easier ones, trying to make you feel better, build the confidence a little bit. I got one more confidence builder, and then we're gonna do a harder one, and then we'll do a couple easier ones. All right. So this is very similar to the last one. The only thing is the exponential expression is not by itself. You always want to get this by itself first. It already was here, and it already was here. So I just got to get rid of that 8. How can I get rid of that 8 and put it somewhere else? I don't want to take a log yet. Before I change anything to log, I want to have the exponential by itself.
Can you move it to the other side?
I need to move it to the other side. Divide
By 8.
by 8. So if we divide both sides by 8, that's gone. And now the problem is just like the last two. You have an exponential equals an argument, what will become an argument. All right, so if we rewrite it, it's x equals log base 3 of 5/8. Is there any question how you would type that in and get a decimal answer?
Yeah, how would you?
Type it in. So you do it just like the last one. Log of the argument divided by log of the base. And there's your answer, negative 0.43. Now, if you're like, well, wait a minute, I didn't think logs could be negative. They're not. 5/8 is a positive number. 3 is a positive number. I didn't say the answer can't come out negative. You just can't type a negative in to start with. Okay. And we didn't. So the answer is negative 0.43. Okay. Any questions on that one? All right. This one. All right. So it's 5 to the x minus 2 equals 3 to the 3x plus 2. So when we solve this one, what's going to happen is you're going to start to see the word log in a lot of places. And I think that's what is going to confuse people, because you're going to see log written like 3 or 4 times. So once you start seeing that, the word log has 3 letters in it, and you see it like 4 times, so it's like you got 12 letters on the board, and it just looks confusing. But I'm going to show you an example that I think if I show you that, you'll be able to do this one at the same time. So what makes this a little more complicated? Like, why wouldn't we see something like that in Algebra 1? Yep.
Because the exponent has variables in it.
Yeah, you've got exponents with variables. If you had something like this, this is totally different. That's just basic distributive property and then solve it. Okay. But we don't have that.
That's what I like.
We're going to have distributive property eventually. Now, if we could, what would we like to do with these exponents? And we have a rule for it. Well, we can't get rid of them, but we can do something with them.
In front of log?
Put them in front of what?
Log.
Log. So you can put them in front if you have a log. We don't have a log. So
Make a log.
let's make a log. Let's just put log in. And if you're like, well, how come you can just put log in? It's kind of like, well, how come you can just take the square root of both sides there? Because you can. As long as you do the same thing on both sides, you can do whatever you want. So let's do it on both sides. Take the log of everything on the left. So 5 to the x minus 2 just became an argument. And log of 3 to the 3x plus 2. So now that just became an argument. Now what can I do with the exponents? Yep.
Move them in front of the log.
Move them in front. So I got x minus 2 log 5, or times log 5, equals, and now put the 3x plus 2 in front. 3x plus 2 times, I still have log 3. Any questions on that step? Now, what you have here, I'm just going to write this down. You don't have to write this part, just watch it. You basically have something like this. X minus 2 times a number. Log 5 is just a number. If I really wanted, I could figure it out. It's 0.7, roughly. So it's like you have 0.7 in that box. I'm not going to write it as 0.7 as I go through the problem because that's rounded. It's going to mess up my answer. And then what you have here is 3x plus 2 times something else. It's times what? It's times the log of 3. That's about, let's just say 0.5. Okay, again, I'm not going to keep it like that because that'll mess up my accuracy. That's what you basically have right there. If you had this, okay, right here, what would be your next step? Distribute. Just take whatever this is, multiply it to both. Take what that is, multiply it to both. That's exactly what we're going to do. We're going to distribute, but we're not going to call it 0.7. We're going to call it log 5. And we're not going to call it 0.5. We're going to call it log 3. So this is where we're going to start to see the word log written a lot of times. But remember, it's just a number. We're just not writing what it is right now. Right, so let's distribute that up. So we have x log 5. Copy down the minus 2 log 5. So that's the part on the left. Anyone think they can tell me the part on the right?
3x log 3.
So 3x times what we're distributing. And then what sign comes next? Plus sign.
2 log 3.
Plus 2 times what we're distributing. 2 log 3. Now, that's the part where people are usually like, what's going on? All right? Let me show you something else again, and I think you'll see what to do with the next step. What did we say log 5 was? It's about 0.7? That's what we said. So what you have there, it's like 0.7x minus, I don't know what that number is, but it's just a number, equals. Okay, and then on the other side, we said log 3 is, was that about 0.5? So that's like 3x times 0.5. It's, I don't know again what that is. It's just a number. Plus another number. I'm not sure what 2 log 3 is. We've got x's on each side. When you're trying to solve an equation, what do you usually do?
Put all the x's on one side?
Yeah, you put all the x's on one side. So what I'm going to do is I'm going to put all the x's on one side, and I'm going to put all the numbers on the other. So everything with x will be on the left. Everything without x will be on the right. That's the next step. All right, so let's do that. Let's move all the x's to the left. How would you move 3x log 3?
Minus it.
Yep, you'd minus it. That's gone. And now we got it on the left. Now, x's are on the left. We're going to put things without x's on the right. So how would I get rid of negative 2 log 5?
Add it.
Add it. I don't know what it is, but whatever it is, just add it. Okay? Eventually, we're going to write it out as a decimal, and we'll get an answer. So plus 2 log 5 to the other side. And don't try to get creative or fancy. There's nothing you can do we just pretty much are going to write exactly what we have. I'm just going to clean it up a little bit. So I have x log 5 minus 3x log 3. Can't do anything with that. On the other side, we got 2 log 3 plus 2 log 5. Again, you can't do anything with that either. And I suppose you could combine them into a single log, or you could put the 2 back as an exponent, but you really don't need to do that. We're just trying to get x by itself. That's all we want to do. So should we simplify other things that are on a different side that's not with x? I wouldn't bother with it. Just look at the stuff that's with x now. All right. So we have 2 terms, this one and this one. If I wrote something like this, I'm not going to use decimals. Let's just say x times 5 minus 3x times 2. If I wrote something like that, what do both of those have in common? They both have an x in common. When 2 things have the same thing in common, you don't need to write it twice. You can just write it once by doing what? Not combining, but it's the opposite of distributing. What do you call it when you, we did it once today earlier with a quadratic. Factor. Whenever you have the same thing written twice, you can factor it out and just write it once. So instead of putting the x twice, we're going to put it out in front once, and that's going to be our second to last step to getting x by itself. Yeah?
Where did you get negative 3x times 2?
I just made that up.
Oh.
So I'm just showing you it's something similar to what we have up above without all the word log, because I think the word log is usually what confuses people. But logs are just numbers. Just decimals. That's all they are. So let's factor an x, there we go, out of what we have up above. If you factor an x out of the first term, what are you left with? Log 5. If you factor an x out of the second term, what are you left with? 3 log 3. And now the other side, just keep it the same. We don't have to bother with it again. The right side stays the same for the rest of the problem. So now what we have is 11 times a number equals a number. Okay. The equation you have is basically like this. That's where you're at right now. We just have to get x by itself. So how do we finish it off and get x by itself? Joe?
I wasn't paying attention. I was just.
What do you divide?
Yeah, what would you divide by?
Log 5 minus 3 log 3.
Yeah, you divide by whatever's right next to your variable. So if it was x times 5 equals 12, I would divide by what's next to x. If it's x times all this stuff, I would divide by all that stuff. And then I have x by itself. So as long as you really understand what you're doing when you solve an equation with algebra, the fact that the word log is in it means nothing. That doesn't change anything at all. All the same steps you know. It just looks more confusing because you're not writing out actual numbers, you're writing the word log. So divide by that number, and divide by, same thing over here. What's it? 3 log 3. And that's our answer for x. This is gone. All right.
Oh, whoa, whoa.
Did you need to see what that said?
No, I got it.
You got it? Now, if they want us to do that out as a decimal, what I would do is I would do it in steps. Because if you try to type that in all at once, you're probably going to make a mistake with something. So I would do 2 log 3 plus 2 log 5. just do the top first. So we get about 2.352. So 2.352 divided by, now do the bottom separate. Log 5 minus 3 log 3. That's negative 0.732. And now divide them. All right. If you want to do it all at once, you can, but most of the time people make a mistake. So 2.352 divided by negative 0.732. This is just tedious at this point. Just typing it in. Negative, it's about negative 3.21.
Would you rather have the more accurate answer up top or about negative 3.21?
If you do about, that's going to be fine on a problem like this. Yeah. The only thing you don't want to do is like round this to 0.7 and round this to 0.5. Because if you round it at the very first step and then you continue using it rounded, by the time you get to your last step, it's going to be all messed up. The accuracy is going to be pretty awful. So it does look more confusing if you have to write the word log, but it's more accurate if you don't round to the end.
Can like the log 5 cancel out since you're dividing by them? Like we did 2 log 5 divided by log 5, would it be 2?
Yeah, you can't cancel. Remember when we had trig identities and I said if you had a plus sign, you can't cancel across a plus sign? Same idea. Right. So it's kind of like if you had 2 plus 5 divided by 5 minus 3. And you said, oh, can't I just cancel the 5s? No, you can't cancel them. Even though they're the same number.
If they're multiplying each other?
Absolutely. If they were multiplied like this, 2 times 5 divided by 5 times 3, definitely. And the answer is 2/3.
So you could have, like if those are multiplying, you could have like 4 over negative 3.
Yeah, if they were multiplied. You won't have one where it's, it'll always be like that though. It won't ever be multiplied. Unless you make a mistake. It should be added because it was a distributive property. Yep. Yeah.
Before, could you have taken out the 2 in front and put it in front?
Taking the 2 out and made it like an exponent?
Mm-hmm.
You could, yeah. I didn't just because it didn't really help me to get x by itself. But absolutely, if you wanted to do this, and then say, you know what, 3 to the 2nd power is just 9, you could simplify that. And you could do the same thing here. You could put the 2 as an exponent on the 5 and say, oh, that's
No, I
just...
meant could you put the 2 in front, like,
2 times log 3.
could you put in, like log 3 plus log 5
Where are you?
back, it's the same place that we were before.
Let me put it back the way it was. All right, so what do you want to change that to?
So like, instead of having it, could you just have 2 open parentheses log 3 plus log 5 close parentheses?
Yeah.
Okay.
Yep. So he's thinking it as kind of like a distributive property like this.
Mm-hmm.
You could, yep. So you could do that. Again, if you're just trying to get a decimal answer for x, doing that extra work like you're doing or like I showed, it's just more chances to make mistakes, but you can do it. Yeah. So when I did this and I changed that to a 9 and that to a 25, this is just kind of a good review for the test tomorrow. But if you had something like that, log 9 plus log 25, how can you combine those together? We learned that yesterday.
Is it one of the log properties?
Yeah.
You can multiply them.
Yeah, you can multiply. 9 times 25. What's 9 times 25? 225? So technically, that entire top, you could simplify a lot. I wouldn't bother doing it because it's just more chances to make a mistake. But 2 log 3 plus 2 log 5 should be the same as the log of 225. Let's see if it is. Log of 225. It should come out to 2.352. And it does. It's exactly the same thing. So there are ways to simplify it more. It's just not necessary unless you want to. I would leave it like that. Okay. Other questions on that? All right. So that's probably one of the hardest ones, okay? Because you see the word log written a lot. Let's look at this one. So this one's kind of like example 2. Let me go back to example 2 for a second. Let's see if you can tell the difference between this one and example 2. All right, so example 2 was log base 4 of something plus log base 4 of something equals a number. Let's go back to others. Log base 3 of something plus log base 4 of something equals 4.
Bases are different.
The bases are different. So I'm going to start this. I'm not going to go through the whole thing, but the point I want to show you here is you can't combine those together. A lot of people think, oh, it's addition. I'll just put them together as multiplication. Nope, the bases are different. That's like trying to combine an x with a y. They're not like terms. Okay, so that's important to know. That's probably the most important thing that I want you to take away from this. Cannot be combined. And the reason? Bases are different. Now, for this one, that doesn't mean I can't solve it. I could solve it if I started out by doing something like this. Log of x over log of 3. What did I just do? How did I get that from the first term? What's that formula I used called? Skylar?
The change of the base formula.
Yeah, I used the change of base formula. So I have log x over log 3 plus log x over log 4 equals 4. Now it looks, if you think, well, now you've got fractions in there, I do, but now everything is base 10 log. Every base is exactly the same, and that would be helpful if I was going to continue solving it. This problem is kind of like this. X divided by 3 plus x divided by 4 equals 4. That's basically the same kind of setup you have. If I was solving a problem like this, I would multiply everything by 12. The reason? It would get rid of all my fractions. Does that make sense why I picked 12? Right? Because if you multiply this by 12, 12, and 12, now you would have 4x. Now you would have 3x. Because 12 divided by 4 is 3. Equals 48. And now you just have a simple equation with like terms and then divide by 7. And there's your answer. That's how easy this one would be. You just multiply by a number to get rid of your fractions, combine like terms, and divide, and you'd be done. Okay, I'm not going to go through it, but I just want you to recognize that. So, still solvable, even though the bases are different. Let's look at this one. It doesn't look like an overly complicated equation. I mean, it's not like it's miles long. It's like 3 things: an x, an e to the x, and a 2. That's it. The problem with that is you've got a variable in 2 spots. If all I had was this, no problem. That's exponential form. Change it to log form. You can solve it very easily. We did 3 or 4 examples in a row today, just like that. If you didn't have this x, no problem. Remember, e is just the number 2.718. So just subtract e from both sides, and then you get x by itself. So that's okay. The problem is you've got the x in both spots. And you can actually prove that you can't solve that with regular algebra. It doesn't work. So adding, subtracting, multiplying, dividing, it's not going to help. So if you can't really do it by hand easily, another way you can solve things is graphing them. So I'm just going to show you this part and show you how easy it is to solve making a picture. Again, we don't really use graphing calculators a ton in here. I just want to show you how fast this problem can be. I'm going to type in two things. I'm going to type this in first, and then I'm going to type this in second. So the calculator is going to draw two different pictures on the screen. That's the first side, x plus e to the x. Now I'm going to put 2. Now, I'm going to have a picture in blue. I'm going to put a picture in red. They're going to be two different colors. I want to know where the pictures are equal. Well, equal is usually something you use with numbers. What does that mean? If I'm going to draw two pictures, and I want to know where the pictures are equal.
Where the two lines cross.
Yeah, I want to know where they cross. So when I draw my pictures, what you're seeing right there, that's the left-hand side of the equation. What you're going to see next to the red line, that's the right-hand side of the equation. So all I need to figure out is where those two things cross. Well, the calculator can do that automatically. It can automatically calculate where things intersect. I just pick that option, hit enter, and it tells me that they intersect at 0.44, roughly. So my point here is solving something graphically can be super easy, and it works pretty good when you can't use algebra. Right? We don't really get into a lot of problems that you can't use algebra for. The ones on your test will be algebra. But any questions on that idea?
I didn't like it. I want to get that picture.
All right. This is one of the more basic ones we did earlier on. Yeah, you got about 25 minutes. Let's do this one. I think it's a little easier than it's like example 2, but easier. So what makes this problem a little more straightforward is the bases are exactly the same. So I've got two logs with the same base on the same side. What can I do with them?
Combine.
Yeah, I can combine them. What's going to be the base when I combine them? 4. And when I combine them, do they combine as a product or difference? Product. What times what?
X squared.
X times.
X times X times.
Yep. Now, remember we did this before. You had to FOIL it. You had a lot of multiplying. You don't have as much here. It's just a simple, what property? It's just a basic distributive property. All right, so let's do it. What do you get when you distribute out that x? Christian, I started to hear you say it.
X squared.
Yep.
And then minus 3x.
Perfect. X squared minus 3x. Now, you've combined everything you can into a single log. So the only thing you can do now is change this equation to
Exponential.
change it to exponential. Yep. What's my base?
4.
My exponent?
1.
And the argument ends up by itself.
X squared minus 3x.
And from here,
Yeah, but why would the equal 1?
the 1 is right there.
Oh.
So your base,
I think
exponent,
it's better.
argument. And now from this point forward, it's just solving a quadratic equation. Either factor it or use quadratic formula. Let's see if we can factor it. If it factors, we'll solve it. If it doesn't factor, we'll skip it. Because the one on the test factors. What do I want to get this quadratic equal to?
0.
0? I think the easiest way is just to move that over there. Make it a -4. Yep. All right, so now I would be trying to find two things that multiply together to give me x squared.
X and X.
X and x. I have a negative and a negative. So what does that mean my signs have to be?
Negative. Yeah, negative.
Negative, positive.
Negative, positive. Okay, anytime you're trying to factor something with two negatives in it, think about your last terms. You're going to multiply something times something and get negative 4. If you're going to multiply two things together and get a negative,
It's gotta be negative, positive.
it's got to be one of each. Yep. Two numbers that multiply to give me 4 and subtract to give me 3. 4 and 1. And it makes a difference which one we put where. So we're going to try 4 and 1 or 1 and 4.
4 and 1.
All right, let's see. X squared plus x minus 4x is minus 3. Negative 4 times positive 1 is negative 4. Perfect. What would make the first factor 0? 4? What would make the second factor 0? Negative 1. Okay. Now, what do I have to do with those? Try and make sure we don't take the log of what kind of number? A negative. Let's check 4. If you plug 4 in for x, what does that argument become?
1.
Well, the whole log would become 1, but the argument would become 4. So the argument would be positive. What if you plug in 4 here? What's the argument? 4 minus 3 is 1. Is that a positive?
Yeah.
Yep. So you can take the log of both of those. That answer works fine. Let's try negative 1. If you plug in negative 1 for x, what does that argument become?
Negative.
Yeah, it's no good. You don't even have to check the other one. But if you plug negative 1 in for x, negative 1 minus 3 is negative 4. That answer does not work. So what you would do is just cross it out. So if that was like a multiple choice type of question, you'd probably have a choice where both of these were listed, because that's the correct answer. Well, both of these listed with one of them crossed out. Both of them listed with none of them crossed out. Maybe both of them listed with both of them crossed out, so you'd see that's simple. And you just have to pick which one is correct. So you just check your answers, that's all. Any questions on that one? Right, so if you see one on the test, I'd probably give you one more like this, because the distributive property is a little easier than the first one we did, where you had to FOIL. But that's the only thing that was easier. So, all right. So the problems for tonight, I think there's only nine questions. So 1 through 3, all. 5, 6, 9, and 17 through 21, just the odds. Again, just as a reminder, my extra help day is still Thursday, but your test is tomorrow. So if you have any questions, you've got almost 20 minutes. If you want to ask me anything from during the week, once I stop the video, we can do that. Or if you have a study hall, I'm free next period. I'm also free period 9. And those are the times you could come ask me some questions.